Alright, today we're going to look at how to use a neural network. You've just gone through all the theory of a neural network and learning about machine learning, how it's simply done, a very simple explanation, the features of a neural network and how fuzzy logic works to come out with an output. Now with the machine learning, it was talking about how MOFs can be found, and we're going to use someone like a graph like this with an online example, which is just down here, playing with a neural network. And if you click on this neural network example, it'll come to a website like this. Now this looks very similar to what we had on the machine learning video. And we're going to just play with the neural network today. So this is just a free online neural network, and we can get up what the MOF diagram sort of looks like. Now what she had was one hidden layer to the output, so I'm just going to press minus on one of these hidden layers. She only had three neurons, and she had two features. So in this instance, there's a feature of the horizontal and the feature of vertical, pretty much. So we're working in a 2D kind of world. Remember when she said that when we start adding some more, we're working into a 3D plane, adding more MOFs, adding more complexity to it. But we're going to just start with two, have three. Now, for a beginning, we've got a very clear distinction between our two dot points. So we're just going to press play up here and see what it does. So you'll notice here in the output that the test loss has got no problems with it. It's actually perfect. If it's at 0, training loss is 0, the line is flat. So it perfectly segregated the both of these. Remember that she was talking about the weights of these lines, which is just number outputs, which has bias to them, which goes into these neurons. And then you can see where the weight is going through. And you go, okay, whichever our strongest weight, it's going to go into our output and make that line. All right, so that was a perfect test. It worked really well. It worked really easily. How about we start adding some noise to it? So if we add some noise to this line, so say we go up to 25 noise, you notice that it's still got, like for us, we can see that it's got pretty much a clear line. It will just have a couple of dots in this lower half with the orange, and vice versa, it'll have a little bit of orange in this blue. We're going to keep with the same features and hidden layer, and we're going to press play, and we notice that we're getting a test loss, and it's continuously changing very slightly. It might not be noticeable with this test, but this is still running, as we see up here, and the actual neural network is trying to work out where all these blue lines are. Okay, so we've still got a similar line. We've got a couple of oranges in the wrong spots. We've got a couple of blues in the wrong spots. But that's a near perfect neural network working at the moment. So that's using our fuzzy logic. It's got a determination. Okay, well, most likely it's going to be this if this is like that. Now test loss just went up, and vice versa. So let's keep this same noise level and maybe add another hidden layer. So you'll notice it will come up with some information for you. And if you want more information in terms of neural networks, you can just scroll down. It talks about neural networks a little bit more, just very briefly, very simplistically. But we're going to add, say, another three neurons to this hidden layer. And I'm going to use 4 features that we're going to work out. So you can see now we've got more depth to it. It's going to be scanning a lot more. You can kind of see what it's going to output in these hidden layers. And it's going to weight them to come out with an output. So if I press play, we'll notice now that it took a little bit longer to get to this flat line, but the neural network is still working by refining this data, and it's trying to get all these blue dots. Now, it's very difficult to ever get these blue dots with just these features and specifically a blue and orange dot, but you'll notice that it's slightly and slowly refining its search until it gets to a point that it just can't refine anymore, until we start adding more hidden layers or making it more complex. So what I want you to do with this neural network, I just want you to have a play. I'm going to have you have a play with all 4 of these different shapes over here. So we just did this one, and you're going to do the next 3. I want you to come in here. I want you to start with the no noise, see how long it takes to get to the correct output. Shouldn't take long at all. Then I want you to gradually increase the noise, increase the features, increase the hidden layers to see if you can get up to 25 noise and try and get the best segregation possible. See if you can find a really low test loss. So I can get a test loss without even playing with the neurons or the features. A test loss is 0.1010, it's still going up. Loss training is 0.082, and it's dropping. And you notice it's refining and refining. I want to see if you can refine it to the best you can. And once you've done that, I want you to take a screenshot of all 4 of your different datas. So a noise of 25. As many features or hidden layers as you want. And see if you can refine that to get a flat line. Notice how there's separation in my line now. Try to get it as flat as possible to get the least amount of training loss and test loss. And I want you to submit those 4 photos into Google Classroom for me.